Okay, now we know G1 particles travel at the speed of c, and you came to the conclusion really that because gravity seems to travel at c, and light of course is the original speed of c, and electricity seems to be traveling close to the speed of light, that it all should be the same particle. Let's talk about the first sort of unification, meaning how you sort of, okay, I've got a G1 particle, how can that be light and gravity at the same time, the same particle, without any specialness to it? And it sort of originated from your gravity group trying to make gravity into a wave, is that not right?
No, the group I worked with was trying to take a wave and see if I could, what would be the characteristic of a wave that would satisfy the criteria for gravity. So you look at all the possibilities, and one of the final conclusions after quite a bit of discussion, we concluded that if the wave were low intensity, because gravity is weak, if it were low intensity, and if the wave had almost no frequency at all, or the wavelength was extremely long, it would almost look like a straight stream of particles moving in a straight line. So that was the conclusion. If a wave was going to be causing gravity, it should be low intensity, and it should basically have no wave, which would allow it to go through objects, by the way. Well, in the particle model, we changed that low frequency, low intensity wave into a stream of particles with just a continuous stream of particles with no variation in it. It's uniform. And that would be the equivalent of a low frequency, low intensity wave. Well, light is something different. Light does have a wavelength, and what that means is that light seems to come at you and hit your eye, for example, at the right interval rate. If it hits it at the right interval rate, we can see our brain and ours sees the color. So light works a little bit differently. It seems to have a cluster of G1s spaced in time away from another cluster, and as long as this cluster of particles keeps coming at your eye at that rate, you can see either blue or red or yellow. And so we came up with the idea that the stream of particles for light had to be a organized stream with these repetitive patterns of high clusters of G1 particles. You can compare both of those, the gravity at low intensity continuous stream versus a higher intensity repetitive stream, to a shower, where when you turn the shower on very little to make it so it's not very strong, and you have it on continuous flow, you get drops of water coming out of the shower head at a continuous rate, continuous pressure, a little bit like a wind blowing. That shower coming out at low intensity continuous stream is like gravity, whereas if you adjust the volume of water, the strength, turn it up so there's more water, and you put it on a massaging type of, you get this pulsating streams of water coming out of the shower head, which is very much like the G1 particle coming at your eye. And so it's the same G1 particle, there's no difference, it's organized difference. One, steady stream, low intensity, not very few particles in the stream, moving in a straight line. Light is the same way. The particles are moving, each individual particle is moving in a straight line, but they're coming in repetitive groups. hitting your eye, causing us to see the various colors of light from blue up to red. That's why one G1 particle can do both. It's how they're organized.